Okay, so chapter 6. Now, from 6 upwards, we're going to use definitely what we learned about networking and operating systems, and then try to understand what distribution using an operating system in a networked environment may look like. Okay, so 6, distributed objects and components. Now, this will primarily be in concern with files or file transfers and interfaces, because as you all know, you will need an interface or port to port your information or to output your information from one side and to receive information from the other side. So files and interfaces, objects and components. Number 1 is concerned with a so-called task bag interface. Okay, so it says which of the methods in the task bag interface could have been defined, and in particular as a one-way operation. And then it's asking in what way such meaning differ from IDLs. Okay, so as far as the task bag interface, consider parallel jobs. So jobs that are parallel, amongst which there are no dependencies. Obviously, I mean, since they are parallel, they must be independent. Okay, as far as the one-way operation, think of replies. One-way operation, think of replies. So one-way operation cannot have out or in-out parameters as far as the reply. Okay, or must it raise an exception again for the reply, because there is no reply message. As it says, it is a one-way operation. Now, relating to task bag operations, you have a so-called pair out method, which might be used if and only if its exceptions were not or was not needed. And an example is given. So let us assume that you have a server. If such server can or could guarantee to store every pair, and this is not easy because it will need a specific large buffer to map such parameters. Now this is one concern. A one-way operation, those as compared with a pair out, those are generally implemented with a so-called maybe semantics. And this is unacceptable in this case. So in answering the question of in what way does the meaning one-way keyword differ for IDL, this is not the case, or it has nothing to do with IDL. Now, other parameters relating to IDL as defined, this is also an interface description language. Now, this is used for defining the interface of a remote object. Now, if you do this, you will somehow negate the use of a reply. As compared with one-way, one-way is used to specify the required quality of delivery. So you have to choose between using an IDL or using a one-way mechanism. Which mechanism is appropriate? It will again depend on what sort of information is to be transmitted. So the difference primarily is behind the reply. People, there is no reply message when you're talking about a one-way operation. As the name suggests, if you are requiring such to happen, you must go and use IDLs because they will provide such mechanism. The choice is primarily made on the type of data and the circumstances of your bandwidth and links, obviously remote links. And this is question number one. It's just an explanation to this bundle or task bag interface or interface bundle as compared to IDLs. Question number one. Do we have a question on number one, people? Do we have a question on one, people? Okay. Now, question number two takes matters even further. We have defined IDLs. So it says explain why interfaces to remote objects. Now think of IDLs. And in generally those related to CORBA, those do not provide constructs, parameters that you can accumulate, and with specific techniques you fill in those parameters to somehow circumvent the overall link between objects and components. It says explain how CORBA objects, files, can be created in the absence of those parameters or constructs. Now, I have defined CORBA before in previous chapters. Now, with CORBA, this is designed to facilitate the communication of systems. That's why it provides those constructs. Now, those obviously must go from one point to another, and obviously it will propagate, or those will propagate through different platforms. Think of protocol converters. So let us assume that you have a client. This client is to request a service. So if a client could request a server to create instances relating to what this client is requiring, the server from its side will need to provide its implementations. It will do such contrasts. So those contrasts or constructs, okay, should be maintained by the server. Now, relating to the client job, as file size, is it normal file? Is it an audio file? Is it a video file? Does it has to be sent in real time or not, or quasi real time? So it will be more effective for a server to provide an implementation and then offer the interface. Now there is a reason. It is a logical reason. Implementation will grab all clients' requirements. Interface will be some sort of an accommodation for these contracts or constructs. Those constructs which are gathered during the implementation, again, those constructs which are gathered through the implementation will switch on a particular interface to the requirements of the clients or a client. That's why you have implementation before the actual interface to be made ready. So back to Corba objects. Now those can be created within the server in two folds. From the server side, and this is a dedicated scenario. From the server side, it creates an instance, remember implementation, of the implementations class according to clients or client requirements, and then export a remote job which is to be in reference to that client, okay, specifically to that client. This is a dedicated scenario. The second one, which is let us say the default one, a factory method, okay, this creates an instance of the implementation class and then exports a remote job or object reference for accessing its method. Now there is a difference between the two. The main difference is that the first one is dedicated, i.e. functions are going to be provided specifically to client's need. The second one is a default scenario by which some functions that may not be needed by the clients will be thrown to the client itself. Obviously, the dedicated switch or the dedicated scenario will be much more complex to implement, but no bandwidth will be wasted. While the other one, the factory method, it will be easier to construct because it is already there. This is the default scenario or method. But then again, some of the functions, some of the implementations may not be needed by the client. And those are the two different scenarios that Corba objects may provide to those components, and actually those two provide methods of interfacing a client to a server. This is the easiest way to grasp the whole idea. It will overlay some sort of parameters for the components to be linked to specific objects that are required by either the client to the server or vice versa. Okay, question number 2. Do we have a question on 2 people? Do we have a question on 2 people? Okay. Number 3 is a continuation to the previous question. Now, those implementation functions that I was talking about, remember implementation and then the actual interface to be handed in to the client. So it says discuss functions of the implementation repository. Now repositories, think of buffers. Think of buffers. Okay, and this is all to be related to the viewpoint or point of view of scalability and fault tolerance. Now think of scalability, the size of the clients versus jobs. Think of fault tolerance with errors and acknowledgements. So these two. Again, we will touch on things like divide and conquer. So the implementation repository, this is, remember, just a big map, memory map. This is a central location in which data is stored and managed. Just think of a buffer, large buffer. And this is used by the clients, obviously, to somehow locate objects and activate whatever implementations. Remember, you have to implement then interface. Now, regarding the communication issues or the remote object reference. So a remote job reference contains the address of the reference or IR that manages its implementation. Now this is due to the fact that you certainly might have different clients requiring different implementations. However, it could not be the case when you're talking about multicasting. But for the sake of argument, we will assume that each client has got a different type of implementation, but then again, the interfaces may be joint or they may be jointly used. So regarding this interface reference, which relates to a client, now this is shared by clients and servers. Now relative to the memory map or the repository. Okay, now in order to think of scalability, because think of the internet, the vast number of nodes, hops, routers and so on. So to improve the scalability of the system, you will need several IRs. Which one will relate to which job? This must be put into an index. So several IRs can be deployed. Now remember, you have a number of clients requiring different jobs. So the implementations should be partitioned between those clients. Again, remember, not all clients are used or indeed not all clients relate to the same implementation. They could. This is why you have different implementations versus interfaces. Okay, so clients can avoid unnecessary requests because some of the requests might be duplicated, okay, for other clients. Some clients may require the same job as others. So clients can avoid unnecessary requests to a specific interface reference regarding a particular component or interface. If those are to be analyzed, or if they analyze the remote object reference, and this is just a mix and match operation. This is to discover whether they are addressing a request to an object implementation already located. Because, as I said, and this is a specific case, if clients are trying to get the same component or interface, so in order to avoid duplication, you will resort to this, because the request, instead of processing the request 2 or 3 or 10 times, you just process it once and then throw it back in a multicast operation to the other requesting clients. Now this is scalability, because you will be consuming a lot of processing power if you deal with duplicates. So this is the first problem is resolved. The second one, or the second issue, which deals with fault tolerance. Now, regarding fault tolerance, now think of resending messages or resending acknowledgements. Again, the interface reference, this is a single point of failure, i.e. if this is to be somehow discarded or deleted or somehow misrepresented, the whole operation or the whole communication channel requirements is no more valid. So information in the interface references can be replicated. Okay, in this case, remote object reference can contain the address of several IRs. Now, regarding the clients, now the clients must somehow follow a rule. So clients can try those, or can try them in turn if one is unobtainable. This will mean that those duplicates will be thrown to those clients, and those clients in turn will be using those duplicates as required, so that the whole process is not repeated. Because as you remember in question 2, the whole idea is to implement, then to provide the interface. Those interface references have a linkage between a particular mechanism for implementation versus the type of interface. Those pair are to be given to a specific client, of course, per session, and it is the job of that client to preserve this IR for its particular session, and once that session is no longer needed, it can just delete that IRs. So those IRs are thrown to the clients. Clients would use some of those IRs. When I say some, as in depending on the session, because different sessions or different sessions do have different IRs. They should, because as we said, IRs must not have a duplicate between themselves. This will make it easier to somehow tolerate any fault. A fault being related to an IR deleted, discarded, or somehow misused. Just copy required IR, throw them at the clients. The clients themselves can use those IR depending on what session is required. Now, each session relative to a client must belong to an interface. You might, as a client, repeat the process to the same interface. In this case, you will be using the same IR, i.e. implementation / interface. But then again, to generalize, clients might be using different interfaces. Question number 3. Do we have a question on 3 people? Okay. Thank you. Number 4. Back to Corba. Migration. Information migration or objects migration. So it says, to what extent may Corba objects be migrated from one server to another? Now, migration is solely made for replication. Whenever you see migration, you will see replication. And replication, to start with, is just to populate the other server. This is the starting point. Then after, it is called replication for updating. Okay, migrating those. Again, I redefined Corba whenever it is there. I redefined this so you can remember it. Now, those objects those are related to requests. So the requests that are referenced, or let me put it in a better way, the request which is to be present for a session, we will call this IOR, interoperable object references. Now, those identify an object per session. Okay, so those IORs, or interoperable object references, they relate to specific, or uniquely relate to specific object. Now, also the server itself contains the address of the IR. Remember, you must somehow tag the client, negotiate the link, provide the interface. Tag the client, i.e. choose the client. Negotiate the channel, i.e. go through implementation. Send information, i.e. you have chosen an interface after implementation. 1, 2, 3. Okay, so Regarding the interface reference, this can locate and indeed activate those objects relating to Corba within any of those servers. Now the reason of that, remember when I said you have migration, because you have duplicates, clients from all directions, and depending which server is nearby, because those servers carry replicates, they can use those different IRs which are agreed upon. Obviously they are agreed upon per session for that period of transmission. So therefore it will still be able to deal with Corba objects. Now in particular those objects that migrate from one server in a group to another, and it is all because you already have replicas. And this is how different nodes from different sides, just imagine you have let us say 200 by 200 kilometer mesh, 200 by 200 kilometer mesh, and in such you'll have hundreds and hundreds of nodes, clients. In between you have different servers. Obviously the west side nodes would like to communicate with servers that are near to them. Well, near, when I say near to those clients, as possible, because sometimes you might not find a nearby server that will carry the required information requested by a specific client. So this is why it's saying that the Corba objects that migrate from one server in the group to another, i.e. groups of servers, i.e. migration. Now you will certainly have a sort of object adapter. So the object adapter name relating to a specific link, this is the key for the implementation in the IR. Now remember, the interface reference, this will be carried for the implementation part before the interface. Therefore all the objects in one server, those must move together to another server for the migration to be successful. Okay, objects relating to clients' needs, not all objects, obviously. Okay, this, however, you can juggle around with this, or this can be modified by allowing groups of objects within each server. Okay, this will mean that you have to choose what objects per servers, what objects per servers. Remember, we are duplicating. So within each server you must somehow have separate objects adapters. Those will relate to those groups. That's why you must have separate object adapters. Remember, objects, say, let us say from object 1, 2, 3, 4, 5, and you have objects 6, 7, 8, 9, 10. Because they are different, each one must carry its own adapter for the interface phase. Implementation, you will be requiring object 1, 2, 3, 4, 5. Interface, you will port out or port in those objects depending on the type of communication. So again, such can be modified by allowing groups of objects within each server to have separate object adapters. Now make no mistakes, those groups can be mixed, i.e. you can have job 1, 2, 6, 7, 8 in one group, the rest in another group, and so on. This is not static, it is dynamic. It is static only for a session. And obviously, it is the requirement of the client. The interface has nothing to do with the client's need. The client must specify exactly what sort of implementation. And this is the implementation part, to assign what objects are to be called or somehow sent or received. The second phase is how to port them through the interface. Question number 4. Do we have a question on 4, people? Do we have a question on 4? Excuse me. Okay. Now 6, this is just a question that will go through some definitions. It says explain carefully how component-based middleware in general and the EJB or the Enterprise Java Beans can overcome the key limitations of distribution in that layer, or limitations of distributed object middleware, which is a specific layer middleware. Okay, so let us define distributed object middleware. Let us define this layer. This is a protocol, by the way. So DOM is a type of infrastructure, okay, a protocol that allows remote access to remote objects transparently. Remember when we did the control channel, which has nothing to do with the data channel? This is somehow related to the control channel. Okay, so as far as the DOM, you must have an environment for this protocol, implicit dependencies. Now this is related to that protocol or that layer of abstraction. It says component-based middleware can or get around the issue or this issue by having a complete contract with the environment, which is set beforehand. Okay, this is set beforehand. And this is guarantee comes in 2 words: what is required and what is to be provided. So required and provided interfaces. This is related to those guarantees for this protocol or for the DOM protocol to work. This is the environment or the true environment of DOM. Now going to the first issue, which is required. So the required interfaces act as declarations of dependencies. Okay, so what sort of components are dependent and which are or which one comes first. Okay, so required interfaces act as declaration of dependencies on other components, this needs to be there and bound to this component. This is to do with load balancing. Remember, with load balancing, you have to know what sort of link you're talking about so you can load balance all the information from one side to another. Now, such declaration will eliminate implicit dependencies because as the name suggests, this is required, okay? So required interfaces, now this is to act as declaration of dependencies. What are the things needed for those to work together as far as interfaces? Obviously, different interfaces are to be used for the channel communication. Now, EJB comes to the rescue. So for the enterprise Java Beans, now this is a container or a buffer. This buffer is to provide a packet or a number of services, a pack of services, such as transactions and security. And those are actually the most important two. As far as security, this is achieved through the mechanism of dependency injection. Now, because it is a secure channel, you must have some sort of dependency. If it is independent, this means that any outside layer or outside interference or intruder can persist in accessing that channel. But here you have dependency injection, i.e. the channel will be confined throughout a session in some sort of injection of security in accordance to some dependencies that are mechanized by the enterprise Java Beans. Now again, this platform or this bundle of services are all in the process of controlling the transactions in a secure environment. Okay, so this is the first thing concerning EJB. Coming to the programming complexity of the interface, or at least the implementation part to gain an interface. So as far as the programming complexity, this is concerned with the need to make low-level calls, okay, to the platform or to the underlying middleware. Now, according to Corba, a so-called POA or Portable Object Adapter, and ORB, the Object Request Broker, those two come in sequence. They come in sequence, i.e. POA and then ORB. Now, those two actually acts as a broker between a client request. Remember, a client is requesting a job from a server. We are concerned with the implementation to somehow accommodate for an interface. This is to be done in a secure environment. So this will need the attention of the administrator. All in all, you should provide some sort of a linkage for the start and end of the session. POA and ORB will be the main type of links that will provide at least the first initiative for the link to be secure. So those two act as a broker between client request for a server and the object or the distributed object or component. Now, in order for this to be completed, this session must start. Remember when I said you start with the POA and then the ORB. As the name suggests, portable object adapter. This has to be consumed first, and then you consume the second one, which is the object request broker or the dealer. Okay, the whole burden will be on the ORB, but the ORB cannot start without preceded by the POA. Now, this offers a relatively sophisticated interface. Sophisticated in terms of the security, because this is a security matter. Okay, for areas such as the creation and management of object references, and this is all to do with security. So you see, different protocols come into different layers to serve the same end produce, which is the requirement of a transmission data from a client to a server, or vice versa. Now, the whole management part throughout that session, or the management of object life cycle per session, obviously, which is concerned with the activation and the passivation, i.e. ending the session, because once you start a session you must end it. So activation of the session, i.e. starting the session. Passivation of the session means that you have to declare the session being ended. Okay, policies, quality of service, for instance, is one of them. So management will deal with those. Policies actually are mapped, or policies for mapping to the underlying platform resources, what sort of resources are required. Now this will all be dependent on what sort of groups are being or are to be maintained. Remember, you have different groups. Each group has got different components. Components is, let's say that you have 10 components. Remember the example, 5 by 5. You have 2 groups. Remember, you have a mesh that is linking different clients, so you have different groups, and each group has got different components. But then again, those components may be shared among those clients depending on what session you are talking about. Now, all this must be separated by some sort of sessioning or sessioning layers. So lack of separation of distributed concerns is an issue. Otherwise, you will have overlapped or overlapping or overlapped session, and this is unacceptable. So lack of separation of distribution concerns, this scenario is to add additional complexity to the whole issue of distribution. So as far as this management or managing such lack of separation, distributed system services such as security and transactions services are of concern, because you see, The whole point of having a secure channel is not for that channel to interfere with another channel. Each channel has got its own security needs. Example, type of encryption. Another example is load or payload, because you see different security issues or security mechanisms can tolerate different payloads. The heavier the payload, obviously the harder the security implementation for that channel or for that session. So as far as management or managing the calls to distributed system services such as security or transaction services, this is hidden from the programmer through a so-called container abstraction. Now, relating to the enterprise Java Beans, this is easy or much easier to do because EJB is already built around transparency and security. Okay, it is configured to work with those exceptions. Okay, and obviously to resort to a different mechanism, it is possible, but it is much easier to use the EJB or the Enterprise Java Beans to carry out all the transparency and the security issues. Now remember, transparency, this is to deal with how to control or how to send control signals not using the same channel as the data channel. This is transparency. Transparency means how to use a different channel than the already maintained data channel. Transparency. Security, this is concerned with the data channel itself and how to securely, again, how to securely transmit information from one side to another. And lastly, no support for deployment, which is the worst thing that you can have. All component technologies, they do provide support for deployment or use through the packaging. Now, packaging relating to that infrastructure we started with, those layers, okay, of components with associated architectural description. Architectural description, it means that each protocol is well defined and it is rooted to the other layer of abstraction without interference. Okay, and deployment descriptors. Deployment descriptors, it means that each protocol is defined by a specific name. It's just like when you define, let us say, TCP as opposed to IP, TCP protocol as opposed to IP protocol or Ethernet protocol. You have to have descriptors for each layer of abstraction in order for the platforms to be somehow bundled on top of each other to form a module. Okay, question number 5, people. Do we have a question on 5? Please, if you have a question, say so. Do we have a question on 5, people? Okay. Number 6. Now, 6 is to do with a so-called MMOG. massively multiplayer online gaming or game. Remember, security and transparency is provided by the EJB, Enterprise Java Beans. So it says, discuss whether EJB architecture or container, indeed container, would be suitable to implement the MMOG. Will it provide enough transparency and security? Think of real-time processing, people, MMOG. And also says what would be the strengths and weaknesses of using this EJB. Okay, so back to EJB. As you know by now, it's a container. This provides services for transactions and security. Now, in terms of MMOG, which is real-time, those are different class of applications, as you should know, because first, real-time basis, second, speed for the transactions, apart from being real-time processing, speed for transactions, because as you know, people might come in and people might drop out. So speed of transactions means that updating whatever listing you have for that session. A session must have listings of users and what user is dealing with what application. So MMOGs, those are quite different class of applications. As an example, they require low latency interaction, nearing real time actually. Okay. Also, they may tolerate weak consistency to support such low latency interaction. Now, for the EJB, or it is likely that the container style interaction, such as our friend EJB, would not be right for such an application. Although it will provide, remember, it is transparency and security, it will support or provide some support for the deployment for such applications. But you see, the snag is, it is likely that the non-functional properties and the associated policies, okay, provided by the EJB or provided for the containers will not be right for this domain. Now, policies, somebody might ask, okay, why such policies are not convenient for such an application? Now, those policies are stringent and they will inflict heavy damages as far as data scrutiny in terms of security, because scrutiny and security means that delays, and you cannot afford for such application to be delayed. So policies will be of concern, obviously. Also, as a note, it's a big point. Note that multiplayer online games would not require full transaction management. Reason? Because you see, once you start to play, let us say, I don't know, chess, once you start populating the map in each GUI or in each side, application side, you just need to refresh a movement of pawns or a movement of the castle or whatever. So you need only to refresh. You don't have to re-establish the whole game from zero or from start. So multiplayer online games would not require full transaction management. However, there would be also question marks over whether our container or EJB implementation would scale in the right way to a large number of online players, because they could be hundreds and hundreds, and they are all requiring low latency interactions. So all in all, transparency and security for the MMOG relating to the EJB does not work. You need a special or a specific way, as we will see in the next few questions. Question number 6, people. Do we have a question on 6? Come on, people, talk to me. Don't go to sleep, or at least stay with me. Okay. Now, in question number 6, we had some sort of a conflict of EJB usage towards MMOG. So, what to do? Question number 7, or 6.7. It says, would Fractal be a more suitable implementation choice for the MMOG domain? Justify your answer. Again, with the massively multiplayer online game, it is much more likely that a successful implementation could be achieved using Fractal rather than EJB. So we have to know what Fractal is actually. So regarding EJB as a container, it provides some sort of a transparency and security. So what is a Fractal? Fractal, now this relates to a component, or at least to a general component. Now this is intended primarily to, and listen carefully, to implement, deploy, manage. Now with management comes monitoring, controlling, and then dynamic, and this is very important, dynamic configuration. So imagine when you compare Fractal, which is dynamic, its parameters can be changed, unlike the EJB. Remember, transparent and security. Once those are set, you must go all the way through that session with those two, transparent and secure, or security algorithm. Fractal does things differently. It is dynamic. It can be changed dynamically, i.e. scalability. Think of scalability. So this will be including operating system and middleware. Now the motivations to this, or to the Fractal, the motivations relating to the feature or features of the model is that it is more lightweight. Now lightweight, don't be misled. Lightweight relates to, remember, it is dynamically configured, or it can be dynamically configured. This, some sort of dynamicity, relate to this being a lightweight or more lightweight. Okay? Why? Because the ratio between the number of, let us say, clients in an MMOG coming in and coming out. Again, the number of clients relating to a particular MMOG coming in and coming out can be somehow dynamically contained using this fractal scenario. That's why it's called fractal, actually. So this is a provision for somehow tailoring the needs of the requirements for the transactions, not just transparency and security. It is a full tailored system that can accommodate any scale. Well, when I say any scale, there is a limit, because otherwise the system will collapse. So this is why when you go in with some games, if you try it, if you go, you have to queue up. It can really happen, but you might queue up. Now, the reason why I say it really happened, because somehow there are other people getting bored and leaving. So the system will accommodate you as a newly arrival person. Oh, this is beside the point. So a lightweight, don't be misled, a lightweight scenario for the fractal. This is all because it is of its dynamic configuration behavior. Now, again, while fractal can support a container-like abstraction, obviously it can implement deploy. Remember, implement, deploy, manage, and with the management you can provide this sort of maintenance by monitoring, controlling, and dynamically configuration or dynamic configuration. This is all under maintenance. So while fractal can support a container abstraction, it is again more lightweight and much less narrow. This is all to do with the system being dynamic. Okay, less narrow in what this offers, and would allow more tailored policies. Now, tailored policies obviously back to what sort of MMOG you are talking about. Okay, for example, supporting weaker forms of consistency. Consistency, the word consistency here relate people to time. Okay, time, i.e. real time or quasi real time or near real time. So the word consistency relate to time. Okay, time, real time or quasi real time. Okay, question 6.7, people. Do we have a question on 6.7? Talk to me. Excuse me. Okay. 6.8 is easy because we already, this is just a recap, because I need this question to 6.9, so that's why I had to include it. It says explain how the container-based philosophy, think of AGB, could be adopted to provide migration transparency to distributed components. So this is just a wrap-up of the AGB and its usage as far as it is a container-based philosophy. So migration, remember, with migration or mobility, transparency is concerned with first hiding the movement of distributed system entities. Remember those control signals, they are put away from the actual data channel from users or programmers, because users and programmers are more concerned with the policies concerning data management and data transmission. They are not really concerned with the control signals, because the control signals belong to whatever hardware and software already there. They cannot just change those. So containers operate by intercepting incoming invocations, obviously invocations from a client to server or vice versa, and making a series of calls to implement the desired level of transparency before, and this is all done before, optionally passing on the invocation to a components. Now, this is just to make sure that the implementation is ready and thereby the interface is available. Think of this problem as implementation or implementations are ready, interfaces can be reached. Okay, that's why it says before optionally passing on the invocation to the components. Now, to implement migration transparency, a container can use a location service. Remember those IRs we talked about? Same thing. To map objects, those are some sort of indices or a number of indices. Okay, to physically locate that object. So those container or a container can use a location service to map objects onto physical locations and then keep track of them, exactly like the IR, exactly like different wording but the same mechanisms. Now the reason why I are using different wording, because somehow they relate to a specific let us say process, which is migration. This is talking about migration in particular. It's not just talking in general about the communication. So with migration comes those two, i.e. migration transparency, relate to a location service, and this to map objects. Now mapping them physically. Now this is just exactly like a directory or a table, and this is obviously dynamic. It keeps changing because different migrations carry different meaning for particular sessions. Okay, 6.8. Do we have a question on 6.8, people? Do we have a question on 6.8, people? Hello? Talk to me. Yes, Sachin. Varma, yes. Okay. Don't get bored, or at least try not to be bored. Last one. Now the last one is just a recap of the RMI. RMI is used for communication channel control. This is a service. Okay, it says consider the implementation of the Java RMI, and here it comes, as a composite in binding or composite binding in fractal. Composite, this is just a word used as a combination. Okay, and it says discuss the extent to which such binding can be both configurable and then reconfigurable, i.e. dynamic. Okay, so RMI, as we all know, this provides a mechanism to create distributed applications. It creates or underlines the path for different nodes in a distributed environment. The RMI provides a remote communication between applications using two objects, and in particular stub and a skeleton. Now stub and skeleton, think of implementation and interface. Remember implementation and interface? Here let us call them stub and skeleton. Now as far as the combination of RMI or Java RMI with Fractal, or the composite binding, now this is all to do with how data is to be represented. So this is a data representation. It is just a way to configure your payload. So like any other configuration in Fractal, this is configurable, or it can be configured and reconfigured, i.e. it is dynamic. That is the meaning of composite binding. This has associated system architecture. It has its own policies, obviously. Okay, in terms of components and binding, this is all to do with different policies regarding those composites. Now, relating to those policies, the scale or level of detail of the composition can also be varied, i.e. different policies can be negated. For example, the communication module, this can further or could be further broken down into different aspects, such as the underlying transport protocol. Now, the reason why it goes deep into different protocols, because you see, when you go from one node to another node, the other node or the second node might not, I repeat, might not be your destination. It might be your transit router. So what the transit router do, it will just pave the way to the source coming from one end, and then overlay a path to its required destination. But it will provide not just a transit way for that packet, it will also duplicate. It will copy. Remember, the question is talking about configuring and reconfiguring. This is why when you send a packet from one side to another, from A to B, it might not go from A to B straight away. It will go to A, C, D, E, B in the first time, and then A, J, K, L, B. What I'm trying to say, the word configuration and reconfiguration means that the route will be different. Why? Because you have some sort of update. Some of the already used routers are no longer available because they are down, because they need maintenance, because somehow it is congested. The meaning of configuration and reconfiguration, it means that the routing table will be changed in accordance to the relationship between A and B. And this is shown in the last paragraph. If you go over the last paragraph, it says this approach clearly lends itself to more configurable approach. It is configurable, it is dynamic. For example, a transport protocol could be configured to TCP or to an alternative transport mechanism, depending on which route you are using. For example, optimized for an ADEC network, let us say wireless. for example. Okay, and I have defined it as far as ADIC, which is a no-local area network that is built spontaneously, just like the wireless. Similarly, the approach lends itself to reconfiguration. For example, changing the invocation semantics. If one router is down, there must be a solution provided. You cannot just discard the whole transmission. You must find another way. So, similarly, the approach lends itself to reconfiguration. For example, changing the invocation semantics and meaning or transport protocol at runtime, i.e. when it's going from A to B, or the intention from A to B is to be maintained, and instead of using the route that you have used a second ago, you use another one during runtime. This is what is meant by reconfiguration. This is all to do with remapping and keep going to your destination. If required, you remap again. 6.9. Question 6.9. Do we have a question on 6.9, people? Do we have a question on 6.9, people? Okay. Now listen to me. I have sent a message to all of you regarding your examination on the 28th. I hope, did you all receive it? You should. Okay, so it's going to be on chapter 1, 2, 3, 4, and 5. 6 is not included. I repeat, 6 is not included. 1, 2, 3, 4, 5. Only the first 5. 28th Wednesday, as the time suggests, from 8 till 10. Be there. You must be there. Okay, don't ever think of skipping an examination. Okay, now regarding chapter 6, if you have a question, please stay on. If you do not have a question, thank you for attending. I am not leaving until the last person leaves. Thank you for attending, people. As always, materials are the one... Oh, wait a minute. People are moving fast. As always, materials are the one you... Yes, sir. Yes, Sachin. Yes, sir. Sachin, don't you think what I provided is enough, my friend? Come on. Cover what I've given you, and I thank you very much. Just cover what I already explained. Okay. Anybody else? Do we have any question? Sweetie. Okay, Sachin. Thank you. Good night. Sweetie, Kola. Sweetie and Kola are not there. Are you there? Well, they are not there. Anyway, thank you for attending, and good luck in your examinations. See you. Bye-bye. Take care. Oh, somebody is coming. Oh, Kola. Yes, okay. Okay, Kola. Okay. You take care.